Welcome back, ladies and gentlemen. This is a video that is going to cover how to write polynomial equations. And we're going to do some where you're using your graphing calculator, so you might want to go grab that. And we're also going to do some where you do it algebraically in intercept form and standard form. So the first set that we're going to work with, you're going to need your graphing calculator for, but you have a little bit of work to do first. You have to use a finite differences to determine what the best model for the data is. So you're probably wondering, what is a finite set of differences? Well, if you were to calculate the distance, so just to make it simple, I made all of my x's increase by 1. If I were to go and jump up by 2 and then 3 and all sorts of stuff, then it would be a little bit more complicated. But what you want to do is you want to make sure that you have a set of numbers that's very easy to work with. So 1, 2, 3, 4, 5, 6 for all of them. But what I did is gave you some numbers for us to determine if this is going to be a quadratic, if it's going to be linear, if it's going to be a cubic. And you do that with a finite set of differences. So this is what I mean by that. How do you get from 2 to 5? You have to add 3. And to get from 5 to 12, you have to add 7. And to get from 12 to 23, you have to add 11. And then to get from 23 to 38, you have to add 15. And then again, you're going to have to add 19 to get all the way to 57. So if all of those differences were the same, we would be done. But they're not the same. So after you try it again, to get from 3 to 7, you have to add 4. To get to 7 to 11, you add 4. To get to 11 to 15, you add 4. And one last time, you add 4. So since it took us 2 tries, this is going to be an x squared, or a quadratic function. Okay? The first row, if they're all the same the first time you try it, it's linear. If you do 2 tries, it becomes quadratic. So naturally, if we were to go do the next one, if it takes more than 1, it increases. So if it takes you 3 tries, it's a cubic. If it takes you 4 tries, it's a quartic. So to get from -3 to 8, or -3 to -8, you have to subtract 5. -8 to a -11, you have to subtract 3. -11 to a -6, you have to add 5. -6 to 13, you add 19. And to get from 13 to 52, you have to add 39. So it's not linear. We try it again. And to get from -5 to a -3, you have to add 2. -3 to a +5, you have to add 8. And then you just keep on asking yourself that question. How do you get from 5 to 19? You have to add 14. How do you get from 19 to 39? You have to add 20. And you still don't have an equivalent set of differences. So you do it again. Now you can see you add 6. We add 6 more. We add 6 more. We found it. So we have linear, quadratic, and this one is going to be a cubic. So this is why you have to find the finite set of differences, because you have to tell your calculator which type of regression you want it to do. So if you just tell everything to be a quadratic regression, you're not going to get the answer right, okay? So why don't you pause the video and try this next one on your own. Click play when you're ready, and we'll see if you got it correct. Okay, so the first set, you would start out by doing -15, and then you end up with -1, then we were at +1, and then we were at +15. And you can see that it's not going to work out for this one. So then the next row you did it, you were at 14, 2, 14, and 50, then -12, 12, and 36, and then finally your last row, you were at 24 and 24. So it took 4 tries, so if you have x to the 4th power for this guy, you are correct. Okay? So the cool thing is once you figure it out, using your graphing calculator is a pretty easy thing to do. So I'm going to show you how to do one of these just to save time on the video, And then you can use your graphing calculator to do the other two. I will show you how to do it with the first one, the quadratic. So once you have your graphing calculator right in front of you, what you want to do is you want to press the stat button. So if you press stat, it's going to ask you to edit a list. Okay, so what we want to do is we want to go to edit. Now to save time with the video, I already typed in the x's into L1 and the y's into L2. So what you're going to want to do is pause the video and make sure you have all of your x's typed into L1 and all of your y's typed into L2. So pause the video and give that a try. Once you're ready, click play and you'll get to see what you do next. So the important part of calculating the finite differences is the fact that you need to tell your calculator which type of regression to do. So once you have this typed in, you press the stat button, and this time you're going to slide over to the calculate menu, and you have now decided it's not linear, it's not cubic, it's not quartic, but this is a quadratic regression. So what you would do is go to quad reg or number 5, and your calculator is going to ask you to make sure that you're working with list L1 and L2. If that is the case, you just have to scroll down to calculate, click enter, and your graphing calculator is going to tell you that it's ax squared plus bx plus c, where a is 2, b is -3, and c is a +3. So now all you have to do is go write down the equation and you are done. So this is y is equal to 2x squared minus 3x plus 3, because your graphing calculator told you a was 2, b was -3, and c was a +3. So your calculator does all the work for you. So if you want to try, what you would do to find the rest is you'd go back to stat, click enter, and you would change your L2 to the -3, the -8, -11, -6, 13, and 52 that we did in the second example. But this time you would have to go to stat, calc, and you would have to do a cubic regression. And in the last one you would have to do a quartic regression. Okay? So you just want to make sure that you find the finite differences first so you can determine which regression you need to use in your graphing calculator. Okay, so if you want to try these on your own to make sure you're using your graphing calculator correctly, for the second one you will end up with y is equal to x cubed minus 5x squared plus 3x minus 2 after you do a cubic regression. And the last one you'll end up with y is equal to x to the 4th minus 12x cubed plus 54x squared minus 108x plus 90 if you do a quartic regression. Okay, so it's all the exact same skill. You type it into L1 and L2. You just have to tell your calculator which type of regression to do. And the last thing we're going to do is do some algebraically when we are given zeros. So we're not given a bunch of coordinates this time, we're just given some solutions to the problem. And we can do this in intercept form or we can do this in standard form. And you always want to write a polynomial of the least leading coefficient that you can, and of the smallest degree. So we could get fancy, but we don't need to get fancy. So what you're going to do is basically look and find out that you have 3 solutions here. You have a 2, a -3, and a 1. Now there's different ways to do this, but what I say is set x equal to 2, then set x equal to a -3, and x equals 1. When we do that, you have to think about, if you were solving, where did those come from? Well, you were set equal to 0. So what you need to do is get these all back equal to 0. So you need to subtract 2 from both sides, and that gives you x minus 2 equals 0. And then you have x plus 3 equals 0 once you add 3 back to the other side. And this would be x minus 1 equals 0. So what you're doing is doing the opposite of solving. So you're going backwards to get things equal to 0. And then you can write it in the form asked for. So in intercept form, that's actually the easiest form. All you have to do is say f of x is equal to, and then you have your x minus 2, x plus 3, and x minus 1. That's intercept, also known as factored form. So whenever you are asked to leave something in intercept form, you leave it just like that in factored form. Now, if this said in standard form, you would have to multiply that all out and write your answer in descending order, okay? But another way to check is you have 1, 2, 3 x's, 1, 2, 3 solutions, okay? The next one we're going to do standard form. But here's the thing. You have to remember something with i's. I's always come in pairs. So this is technically x is equal to 2/3. And x is equal to plus or minus 2i. Now, when we're working with these, you both don't have to be given. We can just say 2i. But you have to remember, imaginary numbers always come in pairs, so it's like saying plus or minus 2i. So let's work with the first one. The first thing you want to do is get rid of this fraction. So you want to multiply both sides by 3. So that's going to give you 3x is equal to 2. And now get this equal to 0, so you have 3x minus 2 equals 0. So it's like, again, you're working backwards from solving. You're getting to where it came from. So if you had 3x minus 2 is equal to 0, you know the first thing you would do is add 2 to both sides and divide by 3, and you'd get 2/3. So you're working backwards. Right before you got to a plus or minus 2i, what you had to do was square root it. So if you're working backwards, the first thing you have to do is square it. So if you're going to square both sides here, you are going to end up with x squared is equal to a -4. Remember, 2 squared is 4 and I squared is a -1. And the plus or minus we don't have to worry about because it came from square rooting. Now it's gone because we squared both sides. And then add 4 back over to the left and you have x squared plus 4 is equal to 0. So you still need to write it in intercept form. So we're going to have f of x is equal to 3x minus 2 and x squared plus 4. But now you just have to multiply it out to get into standard form. So you're going to have f of x is equal to x squared times 3x is 3x cubed. X squared times a -2 is a -2x squared. 3x times 4 is going to give you a 12x, and -2 times 4 is a -8. So that is your answer in standard form. Okay? So that's how you work with those guys. This last one, again, it's a little bit tricky, but you have to think you're just working backwards. So think about where this would have come from if we were solving. So we have x is equal to 0, which is already done, so one of our terms is going to be x. And then we also have x is equal to a -2 plus or minus the square root of 3. So let's think about where that would have came from if we were solving by square roots or completing the square. The step right before this was x plus 2 is equal to plus or minus square root of 3. And where did this plus or minus come from? It came from square rooting. So if we are working backwards, we would be squaring both sides. So x plus 2 squared is not x squared plus 4. It's x squared plus 4x plus 4, because you have to do x plus 2 times x plus 2. Do not ever forget that. And then that's equal to the square root of 3 squared is just 3. But then we're still having to get this equal to 0, so you subtract 3 from both sides, and you have x squared plus 4x plus 1 equals 0. So now we have x times x squared plus 4x plus 1, and then that would be our factored form. To continue and write it in standard form, you would just distribute the x, and you have x cubed plus 4x squared plus x. And you are done. Okay, so that video was a little lengthy because you do have to know how to take time to find the finite differences, and sometimes working backwards is a little bit tricky, but remember, one thing you could always do, if you were not sure if you did that correctly, you could take a minute and say x squared plus 4x plus 1 is equal to 0, and then use quadratic formula or completing the square to see if you get the same answer it came from. So x squared plus 4x plus, leave a little space, is equal to a negative 1 and some space. Half of 4 is 2 squared is 4. Add that to both sides. And then this is x plus 2 squared is equal to 3. Square root both sides, and you can already see where it's coming from. You have x plus 2 is equal to plus or minus the square root of 3. Subtract 2 over, so x is equal to a negative 2 plus or minus square root of 3. The other thing you can do is type your equation into the graphing calculator and see where the x-intercepts are. Now these are obviously going to be decimals, so you can see if your answer matches the decimal representation of negative 2 plus the square root of 3 and negative 2 minus the square root of 3. So really it's up to you. Okay, that's it for real. This is Longo and I'm out. See you, bye.